In 1977, the Voyager 1 space probe was launched to study the outer solar system. The two Voyager space probes have become the longest operating spacecrafts in spaceflight history. 41 years later, Voyager 1 is now 19 billion kilometers from Earth and traveling at 61,000 kilometers per hour. Despite Voyager 1 being the furthest man-made object from Earth, we are still able to communicate with the space probe on a regular basis. But how far can it go before we can no longer communicate with it? To answer this, we need to know how Voyager 1 receives and transmits data from 21 billion kilometers away. A 20 kilowatt signal is transmitted from Earth to Voyager 1 using radio waves. It takes almost 20 hours for the signal to reach the space probe, where its sensitive antenna picks up the signal. For comparison, it takes the rovers on Mars an average of just 15 minutes to send messages back to Earth. Voyager starts sending data back to Earth using a 20-watt signal. As it travels through space, the signal strength weakens, and by the time it reaches Earth, the signal is barely detectable. In order to communicate with objects that are this far away, it doesn't really matter how strong the signal is, as long as you have a receiver that is sensitive enough to pick it up. NASA uses the Deep Space Network, which consists of 3 antenna complexes equally spaced around the Earth. Each complex has a huge 70-meter antenna along with multiple 34-meter antennas, which can be combined to pick up signals that are thousands of times weaker than your standard FM radio signal. The Deep Space Network spends several hours each day listening for faint signals from Voyager 1, and so far it continues to talk back to us. Since our methods for detecting signals have improved drastically over the past 50 years, there isn't really a limit on how far we can communicate with objects in space. With our current technology, we could reliably communicate with objects that are many light years away from us, as long as our receivers are sensitive and accurate enough to pick up the extremely weak signals. As Voyager travels further and further away from Earth, it takes longer to send and receive signals. The signal strength also gets weaker and data rates become slower, making it harder and harder to communicate with the spacecraft. Voyager 1 will continue on its journey indefinitely, and although there is technically no limit to how far we can communicate, our communication with Voyager 1 only has a few years left. Since Voyager 1 is nuclear-powered, its electrical power weakens each day. In 1990, in order to save power, engineers turned off the spacecraft's camera after Voyager took the famous pale blue image, which showed Earth as a tiny blue pixel against the darkness of space. Today, only 4 out of the 11 scientific instruments on Voyager 1 are still active. These instruments are being used to collect data on magnetic fields, solar winds, and cosmic rays outside of our solar system. In around 8 years, Voyager 1 will completely run out of power and will no longer be able to keep its instruments going. Scientists will continue to communicate with the space probe and receive the important information it gathers until it eventually sends its last bit of data and disappears silently into space, never to be heard from ever again. So although the end is near for the Voyager space probes, we can appreciate the incredible journey they have been on and the valuable science they have taught us. Thank you to the Primal Space patrons who helped to write and research each video. If you'd like to contribute to Primal Space, please visit patreon.com/primalspace, where we will be doing a giveaway of a Saturn V Lego set once we reach 50 patrons. So make sure you're subscribed so you can join the discussion as we continue to learn more about all things space. Information from a distance of 21 billion kilometers. The communication process relies on radio waves. A powerful 20 kilowatt signal is transmitted from Earth to Voyager 1. However, even at this strength, it takes almost 20 hours for the signal to travel across the vast distance of space, and as Voyager 1 travels through space, its signal weakens significantly. By the time the signal reaches Earth, it is almost imperceptible. However, this is not necessarily a problem in space communication, because the key factor is the sensitivity of the receiving equipment. As long as the receiver is strong enough to detect these faint signals, communication remains possible. NASA employs the Deep Space Network, DSN, to maintain this communication. The DSN consists of 3 large antenna complexes, strategically placed around the Earth to ensure constant contact with distant spacecraft. Each complex is equipped with a massive 70-meter antenna, along with several 34-meter antennas. These can work together to amplify signals, enabling them to pick up communications that are far weaker than typical FM radio signals, which are thousands of times stronger. The Deep Space Network spends hours each day tracking faint signals from Voyager 1, and even though the signal is extremely weak, it still successfully receives data from the spacecraft. In fact, advancements in detection technology over the past 5 decades have expanded the range at which we can communicate with objects in space. Our current technology allows us to reliably communicate with objects that are many light years away, provided the receivers are sensitive and accurate enough to pick up the increasingly weak signals. As Voyager 1 continues its journey through space, however, the challenges of communication become more pronounced. The further Voyager 1 travels, the longer it takes for signals to reach it, and the weaker the signals become. Data transmission slows as the spacecraft moves further from Earth, making it increasingly difficult to maintain reliable communication. While technically there is no defined limit to how far we can communicate, Voyager 1's nuclear-powered system is slowly losing its ability to transmit and receive data. Its electrical power is slowly dwindling every day, and in about 8 years, Voyager 1 will run out of power entirely and will no longer be able to keep its scientific instruments running. Looking back at its journey, Voyager 1 has already provided invaluable scientific data, contributing immensely to our understanding of space. In 1990, engineers turned off the spacecraft's camera to conserve power after it took one of the most iconic images ever captured, the pale blue dot, which shows Earth as a tiny, faint blue speck in the vastness of space. Today, only 4 of the original 11 scientific instruments on Voyager 1 are still operational. These remaining instruments continue to gather data on various aspects of space, such as magnetic fields, solar winds, and cosmic rays beyond our solar system. In the coming years, scientists will continue to communicate with the space probe, receiving important data until the day it can no longer transmit. Eventually, Voyager 1 will send its final signal and fade away into the silence of deep space. This will mark the end of a historic journey, but its legacy will remain as one of humanity's greatest achievements in space exploration. Although the end is in sight for the Voyager probes, their journey has been nothing short of extraordinary, and the valuable knowledge they have given us continues to inspire scientists and space enthusiasts alike. Thanks to the efforts of the Primal Space patrons, who help fund the research and writing for videos like this one,